Alright, so we're going to do a bit of grade 10 analytical geometry. So analytical geometry is also called coordinate geometry. So we have a few formulas that we use in analytical geometry, and the first one is the distance formula between 2 points. So if we're given a point A, that point A, we can say the first x coordinate, we can call it x1, and its y coordinate is y1 because it is the first point. So this 1 and this 1 just indicate that this is for the x coordinate for our first point A, x1, y1. The second point B will say the x coordinate is x2 and the y coordinate is y2. So if we want to calculate the distance d, standing for distance, of AB subscript, then we use this formula, the square root of, we take x2, subtract x1, and then we square it, plus y2, subtract y1, and then square it. And we put all of these things under the square root. Okay, so that's very, very important. And then sometimes we have a situation where we have to prove that two lines are equal in length. So you have to show that the distance of those two lines, all right, are actually equal. Okay, so that's very important. Then we have a second formula which we refer to as the midpoint formula. Obviously, now if we're talking about the midpoint, so if for instance we have A and then we have B, and there is a point that is halfway, okay, which would indicate, let's say that that point is C. So that means if we have the coordinates of A, x1, y1, the coordinates of B, since the second point, x2, y2, then basically the formula that we use for midpoint, all right? And I don't necessarily endorse writing an equal sign between, though sometimes in formulas you'll find that they do that. So for instance, this M would stand for, okay, so let's just say that this point, let's just say that the point is C, is M, right? Which is, yeah, then what we would say is M, and then we'd write the brackets. So to get our x coordinate for the midpoint, or the point that's in the middle, to get our x coordinate, we would take the end point of B, the x coordinate of the end point of B, x2 plus the x1, and then we would divide it by 2 to get the x coordinate of the midpoint. Then to get the y coordinate of the midpoint, we would say y2 plus the y1, then we would divide that by 2. Okay, so in that way we're able to get the coordinates of the midpoint. This is called the midpoint formula between 2 points, and obviously you can only find the midpoint between 2 points, so we call this the end point. So to get the midpoint, you must have 2 end points, the points at the end. This is the point at the end at this side, this is the point at the end on this side, and this is the point in the middle. That's why we call it the midpoint. Then the other formula we need to know, which is very useful for analytical geometry, is the gradient formula between 2 points. Now, M here stands for gradient. Small letter m stands for gradient. So this is the gradient of AB. Okay, the gradient of AB. So what we to do here is that these points are simply points that lie on the line. Okay, AB. So we say y2 minus y1 because the gradient is the change of y over the change of x, and the change is the y coordinate, okay, y2 minus y1, and then at the bottom x2 minus x1. Okay, So it is never the change of x at the top over the change of y. It's always the change of y at the top over the change of x. And please, guys, note the order. You must make sure that if you say y2 at the top, then y2 minus y1, then please at the bottom you must ensure that you start back at this point of b, x2. So y2, x2. So the twos, the ones, right? You cannot say y2 minus y1 and then say x1 minus x2. The order is very important for your gradient. Please, please, please. All right. Now, in some cases, I just want to make this point as well, that sometimes when people are calculating, for instance, the distance of AB, sometimes people don't use the numerical, but sometimes people utilize the letters as you see them. So sometimes if you look at the distance formula, you can say the x coordinate of B minus the x coordinate of A, x coordinate of B minus x coordinate of A, the whole thing squared, plus the y coordinate of B minus the y coordinate of A, the whole thing squared. So instead of the numbers, sometimes people use the letters to indicate the x coordinate of each point. So I'm sure you can see that as long as it's x coordinate of B, y coordinate of B, x coordinate of A, y coordinate of A, the difference squared plus the difference squared. Same thing with the midpoint formula. Some people will then say the midpoint is found by taking the x coordinate of B minus the x coordinate of A. Not minus, sorry. X coordinate of B plus the x coordinate of A over 2, y coordinate of B minus plus the y coordinate of A over 2. Same thing with the gradient formula. Y coordinate of B minus the y coordinate of A over the x coordinate of A of B minus the x coordinate of A. So it just depends on who you are, but at the end of the day the formula is very important. Let's move on and speak more about the gradient. Now here's another thing. If ever you have lines that are parallel to each other, something we note about the gradient is that if we have here line 1 and here line 2, we can conclude that if lines are parallel, their gradients are equal. So that would mean that the gradient of line 1 is equal to the gradient of line 2. You can simply conclude that because line 1 is parallel to line 2. Okay, very important that parallel lines have equal gradients. So if you know the gradient of one line and you know that the other line is parallel to that particular line, then you can simply do what? You can simply go ahead and state the gradient of the other line using the line that you are given. Then here's another point. If lines are perpendicular, then the product means the multiplication of their gradients will give you -1. So in other words, if AB and CD are perpendicular, so let's just say if you have line AB and we are told that line AB is perpendicular, this little box here indicates that this line and this line intersects at 90 degrees. So that's 90 degrees means that AB and CD are perpendicular. So if AB is perpendicular to CD, okay, if AB and CD are perpendicular, this is a symbol standing for perpendicular, then and the gradient of AB is equal to 3 over 4, then that means that the gradient of CD is what? So remember that we said the gradient of AB times the gradient of CD should give us a negative 1. So we know that the gradient of AB is 3 over 4. The question is, times what value do we get negative 1? That's an important question. And the answer to that, guys, is simply this. 3 over 4 times what? Times. Now you think about it. What we simply do, and what I say to students, is you take this fraction, you flip it. In other words, 4 goes to the numerator because it was in the denominator. 3 goes to the denominator. And then all you simply do is you change the sign. The product of these two gradients, because AB is perpendicular to CD, the product should give you negative 1. So the gradient then of CD is negative 4 over 3. Simply put, what do? You flip the fraction 4 over 3, you change the sign. So this was positive, now it is negative. Simply put, that's what you do every time that you know that the two lines are perpendicular. Why? Because we are told that for perpendicular lines, the product of their gradients should always give us negative 1. Let's go look at this example. If AB and CD are perpendicular and the gradient of AB is equal to negative 5 over 2, then what's the gradient of CD? Remember, the two lines are perpendicular. So what's the gradient of, if the gradient of AB is negative 5 over 2, what's the gradient of CD? Since the lines are perpendicular, what do? I flip the fraction, numerator 5 becomes the denominator, denominator 2 becomes the numerator. The sign is negative, so the sign here will change from negative to positive. So 2 over 5 is positive. Lastly, if AB and CD are perpendicular and the gradient of AB is 2, then the gradient of CD is what? This is 2. 2 can be written as 2 over 1. Very important. Now what do? I flip the fraction 1 over 2. This is positive. Then this will become negative. Change the sign. So all we do for perpendicular lines to simply write the gradient of the other line is you flip the fraction, you change the sign. Very straightforward and to the point. So let's see if we understand this. To prove that two lines are parallel, we have to prove that the gradients of the two lines are, what's missing here? Hopefully you said it in your head, they are equal. Because we learned that if lines are parallel, their gradients are equal. So if to prove that two lines are parallel, we have to prove that the gradients of those two lines are equal. Lastly, to prove, because sometimes we are required to prove that two lines are perpendicular, we have to prove that the product of the gradients of those two lines is equal to negative 1. Because remember, at the end of the day, 3 over 4 times negative 4 over 3 gives me negative 1. Negative 5 over 2 times 2 over 5 gives me negative 1. 2 over 1 times negative 1 over 2 gives me negative 1. Okay. And then the last important concept that I want us to be familiar with as grade 10s is the concept of collinear. Okay. Points A, B, and C are collinear if they lie on the same line. I repeat, points A, B, and C are collinear if they lie on the same line. Therefore, what do we say about those points when they are collinear? We say that they are gradients. The gradient of AB, the gradient of AC, the gradient of BC. We can say that those gradients are equal. Why? Because when A, B, and C are collinear and they lie on the same line, then it is very clear that their gradients, the gradients between the points, gradient of AB, if we calculate it, should be equal to the gradient of BC. If we were to calculate it, it should be equal to the gradient of AC if we were to calculate it. That's what we would find for collinear points. Okay, hopefully this first video was very helpful. We'll dive into other aspects of analytical geometry as we go along creating.